Hi everyone, in this video we're going to go through 4G, which is determining the rule for the graph of a polynomial. So we'll basically be given a bit of information. Sometimes you might have your expression in factorized form as we have in question 1. We have to find the value of k in this one. So all we're doing is thinking about the information that we have and setting up equations. It might just be as simple as substituting in a point. Other times it might require you to do set up several equations. So I can already see with question 2, we're going to have to set up some equations. All right, so let's quickly get through these. So it's not going to be a long video, and also so my computer doesn't get cranky and die on me. All right, so we've got a cubic. All right, we've got k times x minus 1, x plus 2, x minus 3, and we know it passes through the point 0, negative 24. So all we're doing is so this is our point x, f of x. All right, so remember f of x is the same as your y. So your value of f of x is negative 24. And x is 0. So I'm just going to be substituting in everywhere I see x is 0, and I've already substituted in f of x is negative 24. All right, so let's just do this. All right, so we've got negative 1 times 2 is negative 2. Negative 2 times negative 3 is positive 6. So we're going to have k times 6. Now to get k by itself, we're just going to divide both sides by 6. So k is equal to negative 24 on 6, which is negative 4. Okay, so you're just finding the value of k. It doesn't say to substitute it back into the rule, but if we had to, that would just mean f of x equals negative 4, x minus 1, x plus 2, x minus 3. All right, question 2. I should save as I go just in case it gets, there we go. Sometimes I don't even know whether it saves when I press save. Okay, question 2. A cubic function has the rule f of x equals k times x minus 1 cubed plus c. So this time we've got two unknowns. Usually the number of variables you have, or the number of unknown variables you have, not including x and y, is how much information you need. So we've got k and c, so we've got 2 points here. So remember, this is the value of x and f of x, and this one is x, f of x. So we're going to set up two equations here. All right, so let's do equation 1. I'm going to substitute in the point 1, 6. So we're going to have 6 equals k times x minus 1 cubed plus c. Whoops, that's just... we don't really need to tidy that up just yet. Let's just wait until we can see both equations to decide how we're going to solve them. And then we're going to substitute in 3 and 12. So 12 equals k. Oops, what am I doing? Didn't substitute in the value of x there. I knew when I finished that I made a mistake. Not a mistake, I just forgot something. All right, so let's just get rid of that x. I didn't substitute in for x, so that should be 1. All right, so let's just simplify that. 1 minus 1 is 0, so 0 cubed is 0. K times 0 is 0, so c is 6. All right, so with the second equation, well, that worked out nicely, didn't it? What we need to do is we can just substitute in c equals 6. Now we don't have to really make it any more complicated than it needs to be, because we've already got c equals 6. All right, so let's just simplify this bracket. So 3 minus 1 is 2. 2 cubed is 8, so I'm going to have 8k. And remember, c is equal to 6, so I can put 6 in there. Then we're just solving for k. So I'm going to take 6 from both sides. And I don't like it when I get a fraction, because sometimes I think I made a mistake. I'm so used to, year 7 to 10, you usually get answers that aren't fractions. But what I'm going to do is just pause and check my answer. All right, I'm correct, which is good. I knew I was correct. It's just I made a mistake in a previous video for 4B, and there's no point in going back to fix it. So I apologize for that. I think it was quite an obvious mistake. So hopefully you saw that. So I'm just substituting the value of K and C back into the expression, even though the equation, even though you don't have to, but it's just a good habit to get into, because eventually that's what you're going to be doing. You just don't find the values of K and C, you put them back into the equation. All right, question C. A cubic function has the rule. The graph of the function has x-intercepts at 0, -2, and 2. Find the value of A. So remember, your x-intercepts are when y equals 0. So we can actually make these 3 points. We're going to have 0, 0. And we're going to have -2, 0. And we're going to have 2, 0. All right, so I've only got one. Let me just think. All right, sorry. Yeah, I don't need to use all 3 points because A is the only thing I'm looking for. I'm not going to substitute in 0, 0 though, because I'm not going to get anything. Let's just have a look. I'm going to substitute in 2, 0. Let's see how we go with that. So 4 minus A. All right. All right, so let's get rid of that 2A. Now don't expand this. You're going to complicate it a bit more. So I'm just going to divide both sides by 2A. Okay, so that disappears. 0 divided by 2A is just 0. So I'm going to have 4 minus A. So that means A is equal to 4. Now you would get the same answer whether you substituted in 2 or -2, because you're going to be squaring that x there. Substituting in 0 is not going to give you anything. All right, so you do need to do either -2, 0 or 2, 0. So then so we found A is equal to 4. Again, you don't have to substitute it back into the expression, but you can if you want to. All right, question 4. A cubic function has the rule f of x equals k, blah, blah, blah. The graph of the function has x-axis intercepts at, now let's highlight, 2 and 3. And the graph of the function passes through the point 4, 12. Find the possible values of A, B, and K. All right, so what we've got here, we know the x-intercepts are at 2 and 3. When your function is in factorized form, which it is in this case, all right, so I'm just rewriting it now. We know we've got a repeated factor at x minus A. All right, so it's kind of like x minus A times x minus A. Now that means for the value of the value of A is going to be your x-intercept. It's not going to cross the axes, it's going to sit on the axes, but it doesn't really matter for this question. The value of A and B just comes from your axis intercepts. So remember, for your graph, I just draw the graph here. We've got axis intercepts at, well, it doesn't matter where A and B are. Maybe I should put them over here, because they are 2 and, oops, they're 2 and, well, I know they're going to be 2 and 3, but I'll just explain it in a sec. All right, so your cubic is going to sit on A. So let's say it goes something like that, comes back down and then up like that. All right, so A is a repeated factor because it turns at A. Now, when we're looking at the value of A, remember it can be 2 or it can be 3. So let's say let A equal 2 and B is equal to 3. Now, it can be the other way around. Okay, it doesn't say that A is less than B, therefore 2 would become A. But so we're going to look at two different values of K for this question. All right, so let's do substitute in A and B, or A equals 2 and B equals 3, and the point 4, 12. So we've got to substitute in 4, 12 as well. So basically all we've got to find is K. So 12 equals K times X is 4. So remember I got that from this point here. 4 minus A, which is 2. Square that, and then 4 minus B, which is 3. All right, so let's just solve for K. So 4 minus 2 is 2. 2 squared is 4. 4 minus 3 is 1, so we're going to have 4K. So K is equal to 3. So basically, we can have, this is one possible solution. All right. So it just depends whether you let A equal 2 and B equal 3, or if it was the other way around. So when we let B equal 3, no, what am I doing? A equal 3. All right, A equal 3 and B equal 2. Okay, because remember it doesn't tell us which order they have to be in. We then just substitute also the point 412, just like we did before, but we're going to get a different value of K this time. So we've got 12 equals K. This time our X is still 4, but this time A is 3. Square that. And then we're going to have 4 minus B, which is 2. All right, so 4 minus 3 is 1. 1 squared is 1. 4 minus 2 is 2, so 1 times 2 is 2, so we're going to have 2K, so K is equal to 6. All right, so there's your other possible solution. Now, a question like this, I think they would always stipulate whether A was bigger than B and so forth, so you wouldn't always get two possible answers, but for that one you do. All right, let's move on to question 5. So the graph of a cubic function passes through the origin. So remember the origin is 0, 0. So I'm going to just write that down. It also passes through the points. So we've got 3 other points that it passes through. Find the equation of the cubic function. All right, so we've got 0, 0, and all those. I'm not going to write them again. All right, so with your equation, your cubic equation, we can just write it in expanded form. Okay, just like that. And we're going to find the values of A, B, and C. And D, sorry. Now, because it goes through the origin, that means that's also your y-intercept. So that means your value of D is going to be 0. All right, so that value of D is going to disappear, which I won't. I'll just cross it out. I was going to delete it, but all right. So what we're going to do is substitute. So I've already kind of substituted in 0, 0 to get D equals 0. So we're going to substitute in another point. So I'm going to sub in the point 1, 3. So I'm going to have 3 equals, now I can probably do this in one go. So A plus B plus C. And remember there's no D because D is equal to 0. So our first equation is that. All right, then I'm going to substitute in the point 2, 6. So we're going to have 6 equals, now it's a bit harder. So 2 cubed is 8, so 8A. 2 squared is 4, so 4B, and then 2C. All right, and then let's substitute in the third point, and maybe I can squeeze it in, do you reckon? I'm always very ambitious. All right, let's squeeze it in. negative 1, 10. All right, so we're going to have 10 equals, now be careful with your negatives. So negative 1 cubed is negative 1, so we're going to have negative a. Then negative 1 squared is 1, so plus b. And then we've got negative 1 times c, so minus c. All right, and we've got equation 3. Now, we can solve these quite easily on the calculator, but we need to not use our calculator. So I'm going to just focus on equation 1 and 3 at the moment, just because we don't have any coefficients. All the coefficients of a, b, and c are all 1 or negative 1, a little bit easier to work with. So for equation 1, what am I going to do? I'm going to write equation 1, a plus b plus c equals 3. And I'm going to write equation 3, negative a plus b minus c equals 10. Now, I can eliminate any of these. I'm going to get rid of the a's, and you'll also notice that I'll get rid of the c's also. So I'm using the elimination method. You can use the substitution method of solving simultaneous equations. So a plus negative a is 0, b plus b is 2b, c plus negative c is 0, and then 3 plus 10. Oh my god, I don't like fractions. 13 over 2. Just make sure I haven't made a mistake somewhere along the line. I'm just going to pause and check. No, 13 on 2 is correct. All right. It's always a good idea to check because I don't want to keep going, especially with a fraction. All right, so I know b is equal to 13 on 2, so I need to now get the values of a and c. All right, so what I'm going to do is just put a line there. All right, I went ahead and paused and we just worked it out just because I didn't want to make any mistakes because this is a very complicated one. All right, so I think I ended on b equals 13 on 2. So what I did is I used the same two equations, so equation 1 and equation 3, but instead of adding this time, I subtracted them. Okay, so if we look at this part here, all right, so instead of, when I added the two equations, I just was left with b, but when I subtract them, I'm left with a and c. So I'm basically only eliminating the b. Now, what I did notice, and I might not highlight in pink because it's hard to read, is I just did 2c equals negative 7 minus 2a. I didn't just solve for c because I noticed over here in my second equation that we've got 2c. So I can easily just substitute in for 2c instead of substituting in for c. So I just had to look for little shortcuts like that. All right, so then what I did is I substituted the value of b and the value of 2c. Okay, so there's 2c in yellow, and here's b in pink, and substituted them into equation 2. All right. So a little bit of, solving, bit of algebra. Just take your time. Again, we're going to be left with fractions, which are never nice. But I did get a equals negative 13 on 6, which you'd like to know is the right answer. Now to get the value of, so we've got b, now we've got a. So here's a. I put a square around it because never make someone look for your answer, especially when you've got a lot of working out. And it also helps you go back and check where they were, because you don't want to use, I don't know, maybe you've written it somewhere, but you made a small error and then you rewrote it, or you simplified or something like that. Okay, so then I substituted a back into our 2c. So remember 2c back up here. All right, so I substituted a equals negative 13 on 6, which is here. All right, and then it's a little bit difficult to do, but you just got to deal with fractions. All right, no one likes fractions. That squared was originally around c, but by now my computer doesn't like to cooperate. So there's your value of C, negative 4 on 3. All right, so we found A, B, and C. Now the question does ask for the equation. All right, so remember, here's our equation of the cubic. D is 0, so we don't have to do that. So all we're going to do that now is substitute in for A, B, and C. All right, I'm going to have to keep going down the side of this page. All right, so my equation, you can write either f of x or y, doesn't matter, I'm just going to write y. All right, so y equals, the value of A is negative 13 on 6, x cubed. B was from memory 13 on 2, but let's just check. 13 on 2, so plus 13 on 2x squared, and C is negative 4 on 3x. All right, so there's your final answer. So a bit of working out there, probably as hard as it's going to get, but good to do. Put that in green, why not? Have a bit of colour. Yeah, so a question like this, as long as you can solve simultaneous equations, the hardest part are those fractions, all right? So if you can deal with fractions and just take your time, use your brackets with your negatives, you should be okay. All right, moving on to question 6. How many questions have we got? All right, just question 6 and 7. All right, a quartic this time. Function has the rule, blah, blah, blah. And f0 equals negative 8. So what that is telling us is when x equals 0, y is negative 8. And f of 2, so when x is 2, y is 0. And when x is negative 4, y is also 0. So I'm just reading this here. All right, so basically, there are x-intercepts, 2 and negative 4, and our y-intercept is at negative 8. Find the possible values of A, B, and K. All right, this is similar to before where we've got repeated factors. So our quartic is going to be sitting on the x-axis at A and B. All right, so I can go ahead and say, all right, my equation f of x is going to equal to k x minus 2 and x plus 4. All right, so your values are, in this case, if I was doing them in that order, 2 and negative 4. So remember, this is negative, negative, puts a positive there. So that means that in this case, A is equal to 2 and B is equal to negative 4. But remember, just like that previous question, we could have also the other way around. So we could have f of x equals k. Oops, I forgot my squared on there. X plus 4 x. Oh, what am I doing? Sorry. Oh, no. I'm all good. X minus 2. Sorry. Now, you'll notice that because they're both squared, it's the same thing. All right? So x minus 2 squared times x plus 4 squared is the same as x plus 4 squared, x minus 2 squared. Just means your values of A and B are just different, but your value of K will be the same. All right, so we don't have to go and do both of them to find out the value of K because we're multiplying the same thing, okay, because both brackets are squared, whereas previously, now let me just scroll up. Remember when we did it, which question was it? No, gone too far. Question 4. When we did question 4, one bracket was squared and the other wasn't. But for this question, both are squared, so it doesn't make any difference. So you're going to get the same value of K. All right, let's substitute in now our other point. So the other point we're going to substitute in is this one, 0, negative 8, which is our y-intercept. So negative 8 equals K Now we've got 0 minus 2 squared, so I'm just going to forget about putting the zeros in, and then we've got 4 squared. Alright, so negative 2 squared is 4. 4 squared is 16, so 16 times 4 is 64. So we're going to have 64k. So k is equal to negative 8 on 64, which is equal to negative 1/8. So you can have a equals 2, b equals negative 4, and k equals negative 1/8, or this is your other possible solution, a equals negative 4, b equals 2, but k is still equal to negative 1/8. Okay, so we don't have to do the working out for that one. All right, last question. We're nearly there. Question 7. A cubic function has the rule. All right, so it's already in factorized form for us. So f of 3 equals f of negative 3 equals 0, and f of 0 equals 60. So what that information is basically telling us is that when x is 3, f of x is 0, so there's 1 point. And when x is negative 3, y is 0, so there's our 2x intercepts. And then we've got 0, 60 for our y-intercept. All right, let's substitute those values in. Now, we've got the function f of x equals k. We've already got x minus 2 as a factor. So that means it crosses the x-axis at 2, but our other 2 points are going to be at x minus 3, x plus 3. So I've got a equals negative 3 and b equals 3. Now remember, they can be the other way around as well. I'm not going to go through well, you're going to get the same value of k. So it doesn't matter whether a was negative 3 or a was 3. Okay, so let's find the value of k. So we're going to substitute in now the point 0, 60. So we've got 60 equals k. So we're going to have negative 2 times negative 3 times 3. So 2 times 3 is 6. 6 times 3 is 18. So we've got 18k. Here I was thinking we'd have a nice answer. All right, 60 divided by 18. All right, so that goes in 3 times, and what have we got? 6 over 18 as a remainder. Yep. So 6 over 18 is 3 1/3. Probably shouldn't leave it as a mixed number. All right, so I just checked the answer. Yeah, don't leave it as a mixed number. Let's just leave it as an improper fraction. Not that it would be wrong. All right, so k is equal to 10 on 9. So a equals negative 3, b equals 3, and k equals 10 on 9. And you can have it the other way around. All right, the value of k will be the same. All right, so there's your answers. Beautiful. All right, girls. Bye.